In this video, we are going to talk about colligative properties. And a colligative property is a property of solutions that depends only upon the number of solute particles, not upon their identity. And there's three types of colligative properties that we're going to talk about. The first, vapor pressure lowering, freezing point depression, and boiling point elevation. So vapor pressure is the pressure exerted by a vapor that is in dynamic equilibrium with its liquid in a closed system. A solution that contains a solute that is non-volatile, which means not easily vaporized, always has a lower pressure, vapor pressure, than the pure solvent. So in this first diagram here, set of pictures, it says equilibrium is established between the liquid and vapor in a pure solvent. Now, in a solution, solute particles reduce the number of solvent particles able to escape the liquid. Equilibrium is established at a lower vapor pressure. So, we kind of talked about this when we talked about net ionic equations and dissociation, but say we had 3 moles of sodium chloride. And these were broken up. I would have 3 moles Na+1 and 3 moles Cl-1, which would give me a total of 6 moles altogether. It's going to dissociate into 2 ions, right? So ionic solutes that dissolve have greater effects on the vapor pressure than does a non-dissociating solute. So the next one, say we have 3 moles of calcium chloride. And we break it up into 3 moles Ca+2, and then we'd have, since there's 3 apiece, we would have 6 moles Cl-, so a total of 9 moles altogether. Now the next one, it's say if we had glucose. Say we had 3 moles of glucose, and I know glucose is not an ionic compound. It's molecular. It's made up of all nonmetals, 3 nonmetals. So I know this is not going to dissociate. So it's still going to be 3 moles C6H12O6. Okay, so the decrease in a solution's vapor pressure is proportional to the number of particles the solute makes in solution. So which solution has the lowest vapor pressure? The vapor pressure lowering caused by 0.1 moles of sodium chloride in 1,000 grams of water is twice that caused by 0.1 mole of glucose in the same quantity of water. So, same question, which has the lowest vapor pressure? In the same way, 0.1 moles of CaCl2 in 1,000 grams of water produces 3 times the vapor pressure lowering as 0.1 moles of glucose in the same quantity of water. So, the second type of colligative property, freezing point depression. So when a substance freezes, the particles of the solid take on an orderly pattern. The presence of the solute in water disrupts the formation of this pattern. As a result, more kinetic energy must be withdrawn from a solution than from the pure solvent to cause the solution to solidify. So the freezing point of a solution is lower than the freezing point of the pure solvent. So the difference in temperature between the freezing point of a solution And the freezing point of a pure solvent is called the freezing point depression. So we're going to talk about freezing point depression and boiling point elevation. In a few weeks, we're going to do calculations with these as well. So freezing point, we know, is a colligative property. The magnitude of the freezing point depression is proportional to the number of solute particles dissolved in the solvent and does not depend upon their identity. So the freezing point depression of aqueous solutions plays an important role in helping keep travelers safe in cold, icy weather. The truck spreads a layer of salt on the icy road to make the ice melt. The melted ice forms a solution with a lower freezing point than that of pure water. And the third type of colligative property, boiling point elevation. So the boiling point of a substance is the temperature at which the vapor pressure of the liquid equals the atmospheric pressure. Adding a non-volatile solute to a liquid solvent decreases the vapor pressure of the solvent. Because of the decrease in vapor pressure, additional kinetic energy must be added to raise the vapor pressure of the liquid phase of the solution to atmospheric pressure and initiate boiling. Right? So the difference in temperature between the boiling point of a solution and the boiling point of a pure solvent is the boiling point elevation. So the fluid circulating through a car's cooling system is a solution of water and ethylene glycol or antifreeze. The antifreeze doesn't just lower the freezing point of the water in the cooling system. It also elevates the boiling point, which helps protect the engine from overheating in the summer. So the magnitude of the boiling point elevation is proportional to the number of solute particles dissolved in the solvent. The boiling point of water increases by 0.512 degrees Celsius for every 1 mole of particles that the solute forms when dissolved in 1,000 grams of water. Now, last question here says you have 500 milliliters of 1 molar solutions of sodium chloride, sodium sulfate, sodium phosphate, and aluminum sulfate. Which solution will have the highest boiling point? So what we need to do is, first off, we need to make sure all these choices are ionic, and they are, so they can dissociate. So we're going to break them apart. So NaCl we know has 2 ions. Sodium sulfate's going to have 3, right? Don't forget sulfate's a polyatomic ion, so it's going to stay together. Sodium phosphate is 4. Remember, phosphate, polyatomic ion. And aluminum sulfate is going to be 5. So the number with the highest number of ions is going to have your highest boiling point. So your answer is going to be D. And that concludes our video on colligative properties.